Hello everyone, I am going to show you an IoT project that uses an ESP32 board to send its onboard sensor data to a Raspberry Pi with encryption, specifically the AES encryption with Diffie-Hellman key exchange to be a demonstration of preventing man-in-the-middle security attack during data transfer. There are two folders in the project, one for the ESP32 side and another one for the Raspberry Pi side. Let's get started with this one first. It is written in multi-threading paradigm. There would be 3 threads inside. I'll go one by one. The first one is update sensor data that collects data from the sensors every 10 seconds. And the sensors are these 3 sensors, which measure different things. And it encrypts the collected data and transmits the encrypted data to the Flask server on the Raspberry Pi using HTTP protocol. The second thread is print local time. What it does is just updating and printing the current local time every second. And the last one is update with NTP. It synchronizes the time with an NTP server every minute. Now let's talk about the Raspberry Pi side. It handles the Diffie-Hellman key exchange, decrypts the received data, and obtains the JSON format sensor data to display on a web page. Now let's dive into the code. Let's look at this one first. There are many folders, right? But what we are focusing is this one, which contains main.cpp file, which is uploaded into the ESP32 board. First, we include libraries and define global variables such as Wi-Fi stuff, time formatting stuff, variables to store the sensor values, the parameters for the Diffie-Hellman algorithm. Then we define functions like print local time, which prints to the serial monitor, and update with NTP, which synchronizes the time with the NTP server. This function is a modulo function that is used right here to generate Diffie-Hellman keys. The next one is a function for handling the key exchange. It prints the received public key from the Raspberry Pi and the share secret, which is derived from the received public key. And it also sends the public key to the Raspberry Pi. The next function is format data, which gathers all the sensor variables and formats them into JSON response. Then it assigns the encryption key and IV, and then do the padding before encryption. Then it encrypts the data and convert to base 64 so that it can be sent by the HTTP protocol. Okay, the next one is update sensor data that reads the sensors and stores the values in the variables. Here comes the setup function. This is for Wi-Fi connection. This calls the format data function at this endpoint, and the Diffie-Hellman key generation and the key exchange at this endpoint. Then starts the server and prints its own IP address. The remaining code is for the sensor initialization, and this part is for multi-threading. Then the void loop function. It prints this word and the public key and shared secret every 1 second. Now we can test the functionality of the ESP32 board by the serial monitor. Okay, we see that the public key and the shared secret are 6 and 6. So if we go to this endpoint, we should see 6. Yeah. And if we go to the sensor endpoint, we should see the encrypted data. And this one is for the Raspberry Pi side, but I want to show you that it receives 6 and displays here. Now we can go to the code in the Raspberry Pi side. It's app.py that we are focusing. Okay, first we import the libraries and define the ESP32 IP address, and then the parameters for the Diffie-Hellman algorithm. And we generate the private key here and calculate the public key and initialize the shared secret here. Then this route is for serving the web page using this library to load the HTML file in this folder. Then the route for the key exchange, it makes a request to the ESP32 at this endpoint with this parameter. And once it receives the response, it gets the ESP32 public key and compute the shared secret and print it out. The next route is sensor. It makes a request to this URL and then it removes the extra spaces or new line characters and decode and decrypt using the shared secret. This is the same as in the ESP32. Here decrypts the data and removes padding and decodes the data to text using the UTF-8 so that we can read it and obtain the JSON using this function. So what we should see is like this, the decrypted data, like the original one. And then if we go to this route, we should be able to see the web page, which updates every 3 seconds. This interval is set in the JavaScript code inside the index.html file. And that's it. Thank you.